Earthquakes are vibrations caused by rock breaking under stress. The rock breaks and moves along an underground surface called a fault plane. This movement is usually very sudden and releases a lot of energy, which is transmitted through the rocks as seismic waves. This event is measured on the moment magnitude scale. An increase of 1 unit of magnitude is equivalent to 10 times the amplitude and 30 times the energy. This means that a magnitude 2 earthquake will release 30 times the energy of a magnitude 1, and a magnitude 3 earthquake will release 900 times the energy than a magnitude 1. The point where an earthquake originates from underground is known as the focus. The location directly above this on the Earth's surface is known as the epicenter. Earthquakes create 3 different types of waves: P, S, and surface waves. The P waves, or primary waves, are compression waves. They're also known as push-pull waves. They travel the fastest and are the first waves to be detected. S waves, or secondary waves, are shear waves and move in a side-to-side motion. They're the second wave types to be detected. The last waves to be detected are surface waves that roll along the surface of the Earth. They are the most destructive waves as they make the ground move up and down, but they also lose their energy the fastest and cannot travel as far. The waves are detected and recorded using a seismometer to create a seismogram. Seismologists can determine how far away the earthquake struck by plotting the difference in the time of arrival between the P and S waves on a graph. Seismologists can determine the epicenter by drawing circles on a map, showing the radius of the distance from the earthquake of 3 or more seismic recording stations. The point where these circles intercept determines the epicenter of the earthquake. This method is known as triangulation. Earthquakes also tell us about the interior structure of the Earth. When there is an earthquake, there is an area between 103 to 142 degrees from the epicenter where no direct seismic waves are detected. However, beyond 142 degrees, P waves are again detected. Scientists have hypothesized that this is due to there being a liquid outer core, which the S waves cannot travel through, and that greatly slows down and refracts the P waves. Earthquakes also help to map out the tectonic plates that make up the Earth's crust. Earthquakes most frequently occur at plate boundaries. By plotting the location of earthquakes over the past month, the outline of the plates becomes clear. However, not all earthquakes happen at plate boundaries. Sometimes there are intraplate earthquakes that occur because of stresses in rocks being released. This is what caused the 1968 Mecca earthquake in Western Australia, which had a magnitude of 6.5 and caused major damage to structures and infrastructure, including roads and railway lines, and injured about 30 people. Scientists are researching ways to predict when an earthquake might happen, such as sampling gases released from underground and measuring built-up stresses in rocks. However, there is currently no way to know for certain where and when the next one will occur and how big it will be.